Hello everyone. Today let's solve the problem number 35, search insert position. So what the question states here, we are given a sorted array of distinct integers and a target value. So this is the sorted array, right? We can clearly see this is sorted in the ascending order, and we have been given the integer target as well, which is basically 5 in this case, example 1 I'm speaking of, right? We have to return the index of the target that is found. We have to return the index of the target that is found. So we have to return the index if the target is found. If it is not found, or if not found, then we have to return the index where it would be inserted in order. Where it would be inserted in order. Suppose let's see here we have been given the target 5, so we already have the 5 in the nums array. So here we are returning the index nothing but 0, 1, 2. 2, right? So let's come to the second example here. Just give me a second. So we have 1, 3, 5, 6 in the nums array. 1, 3, 5 and 6 in the nums array. So here in this case, the target value is 2. 2 we don't have here in the nums array. 2 can be inserted between 1 and 3, 1 and 3. So so range we have to go with the range, right? So 2 comes after 1 and before 3. Basically we can insert 2 here in between. So the index would be basically here 1. The index would be 1. So we need to return the index 1. So this will be 0, this will be 1, this will be 2, right? So here the index will be quite obviously 1. So the target we have been given 7 here, and so we have the last number that we have is 6, right? The last number that we have is 6 because the array is sorted here, right, in the ascending order. We don't have any number after 6. So array is sorted in the ascending order. So the last number we have is 6. So index, quite obviously the index after the element 6. Here the index of 6 is 3, and the next index we need to return nothing but here in this case 4. So the output is 4 here. So the output is 4 in this case, right? So the output that we got here is 2 for the first one. The output that we got here is 1 for the second one, and the output that we got is 4 for the third one. I hope the approach part is completely clear. I hope the approach part is completely clear, right? I mean, sorry, I hope the question part is completely clear. Let's discuss the approach quickly. Let's discuss the approach quickly. So just give me a second here. So first thing that we need to keep in mind is we will be going with the binary search. We will be going with the binary search as we have the sorted array and we have to search for the element and return its index. We will be going with the binary search, right? So we'll be going with the binary search. So here let's consider the same first example that they have given so that it will be easier for us to understand, right? We have already discussed this one. Here we have found the target 5 in the second index. We need to return the index 2, right? Let's see the step-by-step explanation here. So we are initializing the low to 0 and high to 3. Means we are initializing the low to first index, I mean 0th index, and we are initializing the high to the last index, nothing but high equals 3, right? So here we are going with low equals 0, high equals 3. This is fine. So we have to find the mid. We have to find the mid. Mid is nothing but 1 here. Mid is nothing but 1 here. So nums of 1 equals 3. We have 4 elements here in this case, right? So we have 4 elements in this case. We will be calculating mid. So this will be basically mid equals 1 initially. Nums of 1 is nothing but the 3. Nums of 1 is nothing but the 3. Mid is 1 means index 1 I'm speaking of, not the element 1. So this one mid will be 4 by 2, right? So we'll get 4 by 2, 4 elements, 4 by 2. Mid will be 2, nothing but the 0th index. So this will be 1, basically second element. The length, in the length it will be second element, in the index it will be 1 as it is 0 index. So it is the element 3, right? So we have found 3. Target is greater than this one. Target is greater than 3 because target is 5 here in this case. Target is 5, right? So we will be searching in the right half. So quite obviously when target is greater than 3, mid is 3, right? So target is greater than 3. As the numbers are sorted in the ascending order, we will be searching in the right half. Now low we have 2, high we have 3. Low we have 2, high we have 3, and mid equals 2. Mid equals 2. So nums of 2 is 5. Here, see here, index I'm speaking, right? So here low equals 2, high equals 3, mid equals 2, index. So here nums of 2 is nothing but here this one, nums of 2 is nothing but the 5. So 5, whether we'll check 5 equals 5, yes, 5 equals 5. 5 equals 5 means 5, whether 5 is equals to the target or not, 5 is equal to the 5 is equivalent to the target value, right? So we have target 5 and the value that we have found in the array is also 5. So in this case we have to return 2. In this case we have to return 2, right? So we are performing the this one, what do we call, binary search, that ensures we find the correct index and logarithmic end time. So here in this case the output that we got here is 2, which is equivalent to the output that they have mentioned for the example 1, right? So they have which is equivalent to the example that they have mentioned for the example 1, which, yeah, which is equivalent to the value that they have mentioned for example 1. I hope the approach part is completely clear. I hope the approach part is completely clear, right? So we are done with the approach. We are completely done with the approach. Let's quickly discuss the complexities before writing the code. So the time complexity would be big of logarithmic n. Everyone knows the binary search, this one, what do we call, time complexity of the binary search, it would be big of logarithmic n, because we are performing the binary search basically performing the binary search, right? So basically binary search cuts the array in half each time, or into halves, right? In into halves or in half each time. So overall time complexity would be here, it would be big O of logarithmic n. So it would be big O of logarithmic n, right? So what would be space complexity here? Space complexity would be big O of 1. So what would be space complexity here? Space complexity would be big O of 1, because we are not making use of any extra space. We are going with the in-place search, right? So the space complexity would be big O of n here, big O of 1 here, and the time complexity would be quite obviously big O of logarithmic n. So the time complexity would be big O of logarithmic n, and the space complexity would be big O of 1, right? I hope the complexities part is completely clear as well. So we are completely done with the approach and the complexities. Now we are, as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code, right? Let's start writing the code. Now initially, let's initialize the load to the 0th index, and let's initialize the this one, what do we call, high to last index, nothing but here in this case it would be uh, nums dot length minus 1. This is fine. So let's come to the next part. So let's perform the pure binary search, low less than or equal to high. While loop, within the while loop, first condition is we have to calculate the mid. So this will be int mid equals low plus high, low plus high minus low by 2. This is fine. This is just to prevent the overflow. We are calculating the mid, pure binary search, right? So first thing is, in the binary search, if nums of mid, if it is equal to target, then we have to return the mid, right? If we have found the target in the middle, this one mid index, then what we have to do, we have to return mid here in this case. Next, else if, so nums of mid, if it is less than target, then what we need to do, then we have to give low equals mid plus 1. Then we have to give low equals mid plus 1, nothing but we have to move the right. If the target is bigger, we have to move the right pointer. If the target is smaller, then we have to move the left pointer, right? So we are done with the last one. I mean, we are left with the last condition, nothing but if the target is smaller, then we have to move the left pointer, nothing but else we can just write directly here high equals mid minus 1. High equals mid minus 1. Finally, we need to return the low. Means if it is not found, if the element is not found, then low is the insert position. So we have to go with the low here, means we have to return low here. So this is it for the code. Let me format the code once and let me hit the run button. I hope this works for all the test cases, man. So see here, yeah, you can clearly see here sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. The code works absolutely correct in this case, right? I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.